Launch.
Initiating system 1. System 1 loaded.
That didn't work. Now that you've had your lunch, you're going to fall asleep, right? Better not, because I'm a lot bigger than all of you combined. Nobody got that joke. Okay. Anyway, I'm David McCarter. I'm glad you're back from lunch. I'm glad you're at CSharpCorner. I'm glad to be back at CSharpCorner. This is my first time speaking in 3 years in public. I've been going through withdrawal. I needed therapy because I couldn't see you guys. I missed you all, so I'm back, at least for one more day, right? All right, so this is Rock Your Code, Code and App Performance for Microsoft. How many C# developers? Should be most of you, yep. VB.net? One? Yeah, that's the way it goes usually. So all the samples in C#. And I'll give you lots of links at the end, so don't worry about if I go kind of fast. So anyway, I'm David McCarter. I'm a Microsoft MVP, CSharpCorner MVP, patent inventor, architect, developer, crash on aisle 4. So anyway, there's my handles, all that stuff. Can somebody grab the door, close the door, please? All right, this talk is based off of my code performance book, which is out right now. It covers an older version of .NET Core. Here's all the chapters. It's from 3,400. Can someone shut the back door for me? Thanks. 3,400 benchmark tests, and I'm working on the new version now, and everything I'm going to show you today is all .NET 6 and .NET 7, okay? And when I say .NET 7, you might see some things you go, Well, remember, it's not officially released yet, so as soon as it is, I'm going to rerun all these benchmark tests and repost the graphs once it's released next month, okay? Also, 100% of the money I make off of this book goes to the Voice of Slum. So we heard from the Voice of Slum this morning, so I hope everybody goes to thevoiceofslum.org, and please, please help me help the kids and donate today, okay? Also, if you haven't watched who's watched my show on CSharpCorner? Oh, come on. Okay, well now you need to watch it. There's a really great episode coming up next Saturday, so you don't want to miss it. It's all about memory and performance with the expert at Microsoft. I'm not going to tell you who, Well, you can find out if you go to my website. All right. So this is what we're going to talk about today, why we're here or why I'm here, general tips, strings, ref types, and structs, collections. I'm not going to do the last section, unfortunately, because we don't have time. The encore, then it's tea time or whatever, okay? I'm waiting for more people to come in. Come on, hurry up. Shut the door behind you, please. Hey, can you grab the door? All right. Why we're doing this talk? That's one of the bands I do photography for. All right, code performance. Code performance is super, super important. Not only will poor performance upset your users because things are taking too long, but the other thing is, if you don't get all the performance you can out of your code and you go to the cloud, you're going to be paying more money, right? Every millisecond you can save is $1, or I don't know how much. It's savings in money, right? So this is why I'm really hyper-focused on code performance, is because the slower your code, the more you're going to pay in Azure or AWS or Google or something like that, okay? So it's super, super important. Both are very important for now and the future. You should always be planning for the future. Unfortunately, I don't see this done well enough in the real world, but you need to. And memory affects performance, and performance affects memory. So yesterday I had a talk about memory. This is part 2, basically, the performance part, okay? Because they both go together. If you waste a lot of memory, it's going to hurt performance, okay? Here's some real-world stats of a company I worked at. This company hired me temporarily as a consultant, and their biggest traffic days of the year are 2 days in America called Black Friday and Cyber Monday. The rest of the year, their traffic was pretty flat, but those 2 days, it was crazy. It goes really, really high, and they kept breaking down until they hired me, of course. They were averaging about 20,000 transactions per second during these 2 days, with max of 50K transactions per second during these 2 days. So performance for this company is super important because we guaranteed retailers like Nike and other companies like that an 80 millisecond turnaround in our services. So we had to squeeze everything we could out of the code. And that's why they hired me. And for some weird reason, they put 200 gigabytes in memory of Nike's product information. I don't know why they didn't just cache it, but that's what they did. And all of that really, and that 200 gigs in memory really hurt performance on that server, okay? All right, so now here's some general performance tips that are really easy to do. They won't really take much time, and you can get small gains out of this. Everything I'm going to be talking about is small gains, right? But they add up when you're doing 50,000 transactions per second, right? If you can save a second, every second, maybe, that's less money you have to pay in Azure. Thank you, thank you. All right, so as soon as you go back to your projects on Monday, you need to do these steps to start cleaning things out of your projects, because I bet there's things in your project that shouldn't really be there anymore. First thing you need to do is make sure all the using statements are gone out of the top of your classes that you're not using anymore, right? This could slightly affect performance, right? But it really comes into play in the second slide I'm going to show you. So first, go out of your classes and go right mouse click, say remove unused references and get rid of them all, okay? There are other tools out there that will do it too if you can find one. The second step is in Visual Studio, say remove unused references, okay? What this does is it scans your project and sees if there's references that you're not using anymore, including NuGet packages. And if there are, you'll be presented with this screen, and then you just say, yes, get rid of it, and everybody's happy. So now you've decreased the deployment size of your project, so now your deployments will go slightly faster, okay? But I'm not very clean at home, but I'm very clean at code. I like to keep my code clean, okay? And I see people do this still. Senior software engineers do this, and don't do this. Do not set variable types to their default state. Every type in .NET has a default state, right? What's the default state for an object? Null? Yes. What's the default state for an integer? 0, right? So don't set it, because when you're setting it like this, you're making more computer instructions which will affect the performance, okay? So my rule, 99.99% of the time, is only set code default state if it's different from the default state, okay? So for example, if you want to do a counter as 1, you can do that. You can new up a person, or any of those examples right there. That's the way you do it, not the first example, okay? Don't do the other way. Other quick tips: remove empty methods and commented out code. It just clutters up the code and makes it harder to read. You don't need it. That's what source control programs are for, repositories. Just get rid of it. You can get it back later if you need it, okay? Remove unused code blocks, variable types, etc. Again, when we're coding and developing, we might create parameters for a method, and then we stop using them, but we don't remove the parameter from the method, okay? You need to do that too, okay? And do not ignore method results. A lot of people will call a method and not get a result back. You need to get results back. It actually helps the code, and it helps you know what happened during that call, okay? So don't ignore it. There's a new shortcut you can do now. I don't have it up here, the underscore equals. Do that if you really don't care about it, okay? You're done at 6, done at 7. All right, so those are really quick. It won't destroy your code. It won't hurt anything. It will take really easy, a little time to do what I just told you, okay? Especially if you're using refactoring tools like ReSharper or CodeRush, okay? I use CodeRush, and it's free now, so you should use it too. All right, so let's talk about strings, string comparisons. Many string comparisons look like this. So this company that was doing 50,000 transactions per second, this is what they were doing. They were taking some text and doing to lower on it, okay? Don't do that, all right? Unfortunately, it's there. It shouldn't be there. What you really need to do is this. Instead, use to upper invariant or to lower invariant, because this takes into account different languages. If you do to lower, that doesn't take into account the current language setting, okay? These two do, okay? So you're going to see in a second they take a little bit more time, but it's worth it, because someday your program's going to be translated into a different language, I guarantee it, right? And I've seen so many companies shoot themselves in the foot and cost hundreds of thousands of dollars because they don't do this stuff in the beginning, okay? I don't know how many rupees that is, sorry. So here's an example. This is the way you should do it. If you need to compare strings, do to upper invariant, to lower invariant this way. There's other ways to compare strings, but this is the one I want to talk about today. Globalization is very important, so you need to use this. So here's the speed. You can see here, here's to upper and to lower is the fastest, but it doesn't do what we need it to do. So to lower invariant, to upper invariant's right here, okay? So you can see it, they're the second fastest in this, in my benchmark test, okay? So There's always trade-offs in code, and this trade-off is we're going to take a little bit performance hit because we need to support multiple languages, okay? That's more important, really, at this point. Formatting strings. I think the battery's running out. There we go. There's two main methods to format strings in .NET, and you guys should know this. String.format or interpolation, okay? Here's an example of string.format. Like this, we've been doing this forever in .NET. This is newer. The interpolation, we do like this, right? Before I move off the screen, I suggest anything the user sees, you need to use format, okay? You can use this for logging. I wouldn't use this for what users see because you can't globalize it, okay? But you can this one, okay? I'm going to show you here in a sec. So you can see here string format with culture information is the second fastest, and then there's another one there for resources, and there's string interpolation. You can see string interpolation with culture information. It's almost the exact same speed. So in this case, I guess I was wrong. In this case, string interpolation is actually a little bit better. It's about the same. Yeah, it's a little bit better, actually. Cool. Yeah. All right. String builder. You can get really, really big string performance gains by using string builder instead of concatenation, right? String concatenation in .NET is a real performance killer depending how many strings you're trying to connect at one time, okay? So we need to do better. And in this example, what I'm doing, I'm just going through an array, creating a string builder, doing append, and then doing toString, right? So if you have a lot of strings you need to put together, always use string builder, okay? And here's why. Here's concat, here's join. If you do plus plus this, don't do this, right? But these are pretty fast, but the next one should be string builder. So now you can see with string builder, append, I can't even read that. Append format, something like that. But anyway, so when combining a bunch of strings together, especially like I just showed you in the example, always use string builder, right? And in my open source project, I have some code that makes this even faster, okay? But it didn't make it into my talk. All right. So the next thing is regex. How many of you have used regex before? Yeah, so we use regex a lot for pattern matching of strings, finding things in strings. This regular expression here is just looking to make sure there's a word in the string, okay? And you just have a default, and you just do the regex is match. It will turn back true or false, okay? So that's how I see a lot of code do this, okay? And there's also a bunch of options depending on what kind of strings you're looking at. You can ignore case, you can do compiled, you can do explicit capture, single line, you can go backwards, right to left, culture invariant, all those different settings you can do depending on what kind of strings you're going to be using regex against. And you can see here, for my benchmark tests, all of them are pretty close to the same. You can see explicit capture was the fastest, then single line, then culture invariant, but they're all pretty much the same. So luckily, those options didn't really affect the performance very much, right? But remember those numbers. All those numbers are about 6 to 9,000 nanoseconds, okay? And the compiled one is over 6 million nanoseconds, so don't use that one this way. It skewed the graph so bad I had to take it out because it was so much different. Speeding up regex. So this is actually something I just learned from my guest who's going to be on my show Saturday, okay? So in the previous example, we're creating a regex object within the method, okay? Don't do that anymore. Always put regex in a private field in your class, okay? And when you watch the show, you'll learn there's some caching and other things that Microsoft does to make it a lot more efficient. But it has to be in a field, a static field in your class, okay? So here's an example. It's the exact same thing. Here I am compiling it, right? Because when you compile it and then use it, it's going to be a heck of a lot faster, okay? As you're going to see here in a second. And then here's the word, and then you just do is match, okay? But we're using it from the field, not within the method, okay? Now remember the last slide, performance was, what, 6,000 to 9,000 nanoseconds, right? Look at this. Less than 500 nanoseconds for the compiled one. Or probably less than that, probably like 400. See how fast the compiled one is now? Remember compiled was 6 million something, right? Now, it's not even 1,000. Not even close, right? So this dramatically increases the performance of your regex lookups and stuff, okay? So if you're using regex, forget the old way. Don't listen to Stack Overflow. Do it that way, okay? You'll thank me later. Or actually thank my guest after you watch the show next Saturday, okay? I do questions at the end, okay? Okay, so let's briefly talk about reference types and structures. There's not a ton. In structures, you should always override equals, okay? Because equals, if you don't override equals in anything, it's going to use reflection, and reflection is notoriously slow, okay? In .NET, we want to avoid reflection as much as we can, okay? Sometimes we have to use it, but we want to avoid it, okay? So here's an example of a structure that's actually from my open source project. And I put the equatable in coordinates there, and then I do the equals right here, these two equals, okay? Now what's the speed difference? Look at that. That's huge difference, okay? Look at this, override, reflection, say. Remember I just said avoid reflection? This is exactly why, okay? So always override in structures, okay? And while you're doing it, obly implement this for structures. I actually found out that if you do equals on a normal class, a regular class, it actually slows it down. So don't do it for that, just do it for structures, okay? Also, structures don't have operators. So make your users of your DLL happy by implementing the operators, okay? And if you use good analysis tools, it'll kind of ding you and say, hey, you need to implement this for you, okay? Other tips, seal classes. Most people don't seal classes. Seal classes means you can't inherit it anymore, okay? Most classes are not meant to be inherited, right? So seal them, right? Not only does this show intent of the class, right? But it can slightly affect performance, okay? That gets smaller and smaller these days. It was a lot bigger in the older versions of .NET, okay? Always use proper class access modifiers. Again, this is just making sure you're showing the proper intent to the people using your type, okay? This is just kind of a cleanup thing for me. And only use public classes on purpose, okay? Most every class people create is public. Stop it. Unless you mean that class to be used outside of that DLL or EXE, don't make it public, right? That also can slightly affect performance, okay? And this shows better intent again, okay? Implement iDisposable. If you guys were at my talk yesterday, I talked all out 40 minutes about this by using the keyword, and you can also go to my open source project and use dispose collection to dispose fields to help you dispose of things properly, okay? All right. So now the big one. This is where you get a lot of performance increases, collections, okay? And I've been benchmarking .NET 7 since the beginning of summer. And I just completed everything, right? There's a lot of differences in .NET 7. And if you make sure you check out my website, I'm going to be writing a lot about that very, very soon, okay? So creating a collection. This is the common way I see people create a collection object, okay? I've seen this a million zillion times, okay? If you can, avoid this. This is the way you do it. And that is, if you know how many items are going to be in the collection, make sure you set it when you create the object by just like I'm showing you in this example. Gosh, I can't talk this afternoon. Okay? Do it that way. Even if you have a guess, it's going to make performance better. Okay? But try to avoid creating collections without telling it how many are going to be in it. Okay? And you can see here, this is by telling it how many I want. This is if I'm just doing like, I'm guessing half the amount. You can see it's not much difference. But there is a difference down here when you don't do that, okay? And this is actually getting better and better with each version of .NET that comes out. You know, .NET 6, yeah, this is .NET 6. Yeah, .NET 7 seems to be a little bit slower, okay? But always do this if you can. We can't do this all the time, but if you can do it, it'll affect performance. And when you're getting 50,000 transactions per second and creating maybe hundreds of collections during that, this really adds up, okay? There are 4 main ways to loop through a collection in .NET, right? There's for each, there's do, there's while, and there's for, okay? Those are the 4 main ways to loop through a collection in .NET. Most people use for each, because for each is just simpler, there's less syntax, it's a lot simpler, right? I would say 90% of the code I see uses for each, okay? You can see down, I'm sorry the screen, it's even hard for me to read the screen, but down at the very bottom is the for each. You can see it is slower than the other ones overall, okay? So if you can go through a collection, always use for or do or while, okay? But like I said a minute ago, make sure you check out my website because some collections actually work better with for each and some work better with for. And I'm going to be listing all that stuff down for you guys so you don't have to figure it out like I have been figuring it out. Right? But check out my website soon. Checking for items in a collection. How do you check for items in a collection? Who can say? Loud, loud. For each loop? For each? Huh? Count, dot count. Most people use dot count, right? To see if there's items in the collection, right? Usually do a question dot count, right? Just in case it might be null. So here's 3 ways you can do it in .NET currently. Count, long count, and try get non-enumerated count, right? And I did a survey. I'm always doing surveys on my Twitter feed. I hope you guys will check them out. And you can see here 95% of the people said count. Were they right? Oh, wait. I don't have the graph yet. Okay. So use count, right? Count is the fastest. you can see here, see how fast count is compared to try get a numerator count is not too bad, but long count is really bad, right? So avoid long count if you can, because for some reason it really kills performance. I don't understand why. I'm going to have to ask the architect of C# because he's my friend why this is. I'll have an answer. Checking for items in an array. So array is a little bit different. In an array, we don't use count in an array, we use length. Okay? So don't use count in an array, use length. That's the most performant way of doing it. Okay? And when you use length over count, look, 4 times increase in performance, right? Just by using length, okay? And like I mentioned earlier, if you're using code analysis tools, most of them will tell you to do length, okay? In case you forget, which I typically do sometimes. Creating a collection with the loop, okay? So many times we get a collection from an API or a service or a database or something like that, right? We go through it, we modify some data, and we put those items into a new collection and maybe send it on through our API, right? So we do this all the time, is creating a collection from a collection, okay? Here's an example. I have list person. I forgot putting the count on there. I guess I should have. And you just go through, you do something, and then you add the collection right there, okay? Instead, do it this way. If you can, at all possible, send in the new collection, 5 minutes, new collection in the constructor, or use add range. You're going to see here the difference. The constructor, see, they're getting pretty close, right? The constructor is always the fastest, okay? So I would stick with that if you can. And here's what doing this with a for, you can see using capacity, half capacity, and without capacity, you can see again, capacity wins out, okay? So use capacity as much as you can. Which link statement is faster? Who says, I'll let you look at that for a couple seconds. Here's the link API. This is Lambda. Which do you think is faster? Number 1, raise hand. 1 person. Number 2? Yeah? Okay. Let's see. Right now, the API is a little bit faster. You know, the last time I did this talk, it was the other way around. So they've done something, but Lambdas were the fastest way to do it, and now it's the API for some reason. I don't get it. And but you can see here, if I'm doing a where first, you know, through the API or Lambda, in this case, Lambdas are faster than the API, okay? So this stuff really can change depending how you're using it, okay, as you can see in this example. So in this example, if I was doing a query and doing first, I would use Lambda. It was maybe something else, I'd use the API, if I'm really trying to squeeze down the performance. Serializing objects. Forever, we've been using the Newtonsoft JSON. .NET Core now has a JSON serializer in it. Who thinks Newtonsoft is fastest? Nobody? Who thinks the .NET Core is fastest? Yep. When serializing the JSON serializer, the .NET Core one is faster. And for deserializing, it's fastest too. Okay? So if you're using JSON Newtonsoft, I would start switching, because it's actually, .NET is actually faster now. All right, we're almost done. Here's some things that basically have now, there's not a big difference anymore, so do it any way you want. You can do an if that the first way, second way, third way. They're all pretty much the same. I stick with the third way there because I always want to make sure if there's a null in the string. I mean, an empty stuff in the string, okay? But I always use the last one, just to be safe. Returning a new object, you can return objects either in the return or in an out. They're basically the same performance, so don't worry about either way. Null coalescing assignments. Before .NET 8, this is how we did null coalescing. Table equals null. But now we can do it like this. Table question mark equals both pretty much the same performance. Okay, not a big difference. And analyzing code for issues. I thought I took this out. Oh, yeah. Sorry. Oh. All right, almost done. All of these tips are on my website. Okay? So if you go to my website, I have an entire section about code performance. Okay? And a lot of the stuff I just showed you is there. Actually, all of it's there. Okay? Here are your links. Take your pictures. Nobody? I'll put them on my website too for you. All right? How's it? Everybody like this talk? You learned something? Here's some more. Thank you.